Hello, welcome, and thank you for joining us for today's webinar on the advancements of laser engraving technology. Before we begin, I'd just like to say that I'm joining here from Dublin and Brian's joining from Bristol, but if you'd like to put in the chat where you're from, just to make sure that the sound and everything is working correctly. So again, my name is Andrew Dudley and I'm the Area Sales Manager for Trotec Laser in Ireland. And just like to mention before we start that this video will be available on our YouTube channel afterwards if you'd like to watch it back then. I've been with Trotec Laser for over 3 years now, and before that I worked in the mechanical engraving, print, 3D milling and 3D printing industries for over 10 years for another global manufacturer. Now, working for 3 years in the laser business gives me a good understanding of the technology available today. But this webinar is focused on the changes over the years. And to help me with that, I'd like to introduce someone who has a longer history than me in the laser business, Brian Jater. So Brian's the Sales Director for Trotec Laser UK and Ireland. Welcome, Brian. Thank you very much for joining us.
Thank you. Thank you for bringing me along for the ride. It's great to be hosting our first UK webinar. So excited
Absolutely.
to be here.
Yeah, no, absolutely perfect. So I've given a little bit of a history. Please tell us a little bit about yourself and your history in the laser business.
Okay, I came into the laser business 22 years ago as a fresh-faced youngster with a full head of hair, working for a company which sold laser systems, mechanical engraving machines, and also some flatbed printing equipment. Okay. So spent 12 years working in that business, and then made the switch to Trotec 10 years ago. So been a area manager, a sales manager, and now sales director. So I'm hoping that there'll be plenty of questions, and keep them coming on the chat, please, as we go along.
Yeah, absolutely.
So that we can help with. We're going to run through some subjects, but feel free to dot in, and then we'll have a Q&A at the end as well.
Yeah, perfect. Okay, so that's a little bit of introduction for myself and Brian. Just like to spend a second to introduce Trotec Laser for those of you who don't know us. Trotec Laser is the world leader in the field of laser technology. We develop, manufacture and market systems for marking, cutting and engraving, as well as we produce laser engraving materials as well. Trotec's core values are to set new standards, we serve our customers' needs and make them profitable. We do this in over 90 countries worldwide, including the UK and Ireland, and we have over 700 colleagues worldwide to help us do this. So again, this webinar is going to be based on looking at what the advancements in laser technology is. So we're going to have a little look at with Brian about what was about 20 years ago. But before we dive in, I'd just like to ask the chat a few questions. So my first question would be, what advancement have you seen, if you're a laser user, in laser engraving that has been the most impactful for you or your business? So again, that's something, if you want to put an answer to have a think about that as we go along. Maybe there's a topic that we cover that you think, oh yeah, that's definitely something that's made a massive benefit to us. And then also more towards the end of the webinar, we're going to look at the advancements and the future. So is there anything in the future, if you were talking to the R&D team at Trotec directly, what would you say would be the most innovative or most useful thing that you could add to a laser engraver yourself? So again, if there's anything we mention and you want us to explain or ask us a question about ongoing, then please do so. So the topics today, we're going to cover basically 3 sections, or 3 or 4 sections. So we're going to have a little brief history and a timeline of the laser, so from the theory and invention to the present day. We're then going to move on to the discussion with Brian regarding lasers in the past and about 20 years ago, what the market looked like then. We're then going to go into a bit more detail in terms of the innovations that have happened over the last 20 years and perhaps what we feel are the most impactful ones that have come about. And then we're going to have a look at the latest technology that's available today. We'll then open up for the Q&A at the end with a bit of speculation based on what we might think is coming down the line. Okay, so moving on. Laser. So as a history, we need to sort of identify what a laser is, and this is an acronym that stands for light amplification by stimulated emission of radiation. But what does this mean, and why these words? Where do they come from? The way I would probably explain it is it started with Einstein in the early 20th century and his work on the theory of quantum mechanics. Now, the kind of 2 cents or 2 pence explanation of this is that matter, so this is any matter, but maybe specifically for lasers, it would be, you know, your CO2 gas in your laser tube. It has a certain energy state that it likes to be at. This is sort of the natural state. And in Einstein's theory, he says that if you give this energy, if you stimulate this, it will go to a higher energy state, but it wants to return back to that natural state. It wants to naturally, you know, exist there. So it does that by getting rid of the energy somehow. And so he says that if you stimulate it, it might emit that in the form of radiation. So that's where I would say the SER part of laser comes from, the stimulated emission of radiation. We now move to the early 1950s and Charles Towns, and he was a professor at the time at Columbia University in America. He created the maser, so this is the microwave emitting laser effectively, and this is and the microwave radiation is a longer wavelength than visible light. This is where the amplification part comes in, so the A in laser, and this is really a way of increasing the power that was emitted from each molecule of the gas or the material that was excited to something that we could use, so a pulse or, you know, something we can use or detect. We'll then complete the acronym in 1960 with Theodore Maiman, and he was the first to create the higher frequency wavelength emitter, which is a visible light emitter. So he created a laser out of a synthetic rod of ruby, and then that was given energy by a flashlight. So this created a red pulse, so something you could see. So again, this is completing the laser acronym. Generally today we would use the word laser for anything, even if it was a microwave, you know, a maser or anything else. And, you know, that's still the case with laser engraving as well, because the CO2 lasers and the fiber lasers we're going to talk about later, they're all infrared lasers. So moving on, 1964, I suppose this was all rubber stamped really with the award of the Nobel Prize in Physics, and this was awarded to Towns and 2 Russian scientists, Nikolai Basov and Alexander Prokhorov, and they won the Nobel Prize for Physics in 1964 for their work in quantum electronics and the lasers. 1964 was also the year that the laser, I suppose, hit the mainstream, hit more common usage with the release of the film Goldfinger. So this was a James Bond film, and in this iconic moment, Goldfinger was basically testing James Bond's mettle by threatening his most valuable possessions. And again, it goes down in one of cinema's most iconic moments. Now, spoiler alert, James Bond survived this moment. I think he's been in 22 films since then. But as you might guess, it's not something today that we can recommend as a good application for a laser. You know, not something that we would then generally recommend. And you can also see that nobody's wearing PPE there as well, which obviously for a laser you'd want to do. So the 60s and 70s were a golden age for invention, really, for the laser. This is the new technology on the block. This is cutting edge, and people were using it to try and, you know, work out new things, how they could use it, and you know what that, I suppose, led to was a few mentions in terms of the laser printing. So this is something that maybe you have, and certainly I have in the office here, but you know, you might have at home, which is a laser printer. So this was invented by Xerox in 1969, and this is using a laser to put the toner ink onto paper. Again, you know, most people would have an idea of what a laser printer was. 1969 was also the year that the first commercial laser engraver was available. So laser engravers might have been available before then for industry, for specific turnkey solutions, but this was kind of like the first one, I suppose, you could buy off the shelf. This was made by a company called Laser Machining Inc. in America, and its founder was Bill Lawson, and he's credited for the invention of the direct scan method of laser engraving. Now, you might see that you might look at that photo on the right and say that it looks more like something out of a Mary Shelley novel with Dr. Frankenstein trying to reanimate his monster. But it was actually first used by an artist called Tom Zarden, and he used the engraver to create redwood signs. So signs, again, is something that we still use in lasers for today. To put all this in context, 1969 was also the year that man first landed on the moon. So again, cutting edge technology for the time. We jump forward a little bit, so more specifically for, I suppose, laser engraving in the mid 1990s. And this is where we have the addition of subsurface laser engraving. This is a method of focusing the laser inside a crystal, and where that focus point is in that three-dimensional space, that's where the laser effectively frosts the crystal. This is great for, decorative and hologrammatic effects. So most people probably would have seen something like this before. Also in the 1990s, there was an Austrian stamp manufacturer, and they were looking for a way to digitize their existing analog process for making rubber stamps. They purchased a few laser engravers that were on the market at the time to again engrave and cut those rubber stamps. They found them, I suppose, weren't really up to the task. They weren't really up to that high demand task of engraving and cutting rubber. So what they did is they set their R&D department on to basically create something that would be suitable. As you might have guessed, that stamp manufacturer was a company called Trodat, who are the sister company of Trotec. And a few years later, in 1997, Trotec was formed to enable other businesses to benefit from the advancements that they've made in their discoveries in terms of the rigidity and the dust protection, which is sort of critical for engraving rubber. Our colleagues in Canada actually did a laser jam session a few weeks ago with Dr. Andreas Pence, who is our CEO and founder, and he talks more about the formation of Trotec Laser and what it was like back then. So it's well worth checking out on their YouTube channel. 23 years later, Trotec is still the market and innovation leader. We're the first to bring out advancements such as the ceramic laser tubes for CO2 laser engraving, the integrated camera systems for print and cut, and also the multi-source laser machines, so the flex machines as well. So that was a brief introduction to lasers. Hopefully that you found that useful and interesting, and a bit of introduction to Trotec as well. Before we move on, just a reminder that any questions in chat, please put your comments and questions in. If there's anything specifically you want to have a comment on or ask a question about, or again, those questions that I asked in terms of what have you found as the most impactful invention or technology or advancement in laser engraving, and what would you like to see in the future? So for the next part of the webinar, we're going to bring Brian in. I think I've probably talked too much at the moment, and we're going to ask him about what engravers were like back then. So I suppose, Brian, my first question would be, what were people buying lasers for? What were they doing with it, and why were they buying them?
Well, going back 22 years when I first started, the market was not as wide as it is now, mainly due to performance of machines. So we were focusing very much on the trophy market because we could engrave glass, we could engrave all the pre-manufactured awards and things like that.
Okay.
So the trophy market was the main market that we were going on because they were already engravers, those people.
Yeah.
So we had to look at where we had an advantage over mechanical engraving. And the main one that we found at the time was to do with the graphics side of it. So engraving anything with a spinning cutter involves vectorizing graphics or being stuck with a certain number of fonts. And we found that people wanted to have a bit more freedom with the engraving side. That, and of course, the fact that a laser is de-skilling the engraving side of it quite dramatically. So the ability to use a machine like a printer rather than actually needing somebody who could know how to grind a cutter correctly or who could vectorize graphics, if you could just go file print, then that was a big winner for people.
Yeah, lower entry into the market, I guess.
certainly from a skill point of view, absolutely.
Okay, so it sounds like they're fairly similar to what people are using it now, but maybe there's a bit more variety of machines available and applications. So from that, I suppose, what was the specification of machine that you'd be selling back in the day?
When I first started, we had one machine in terms of size, which was a 610 by 457 millimeter working area machine, and 95% of the machines we sold were 25 watts.
Okay.
That really was your only option back. This is 22 years ago, but that really was your only option.
Right.
Shortly after, probably 3 years later, we had a 610 by 305 working area machine, which to me at the time was an absolute godsend because it was much more portable. So it was a desktop machine.
Right.
So rather than having to lug a big freestanding machine around in the back of a van, I could put a much more easy to move machine around in the back of a car.
Okay.
However, they weren't without their challenges in that the rigidity was not very good in the machines, and I had to realign it every time I went anywhere with it. Right. So the setup time when you arrived at somebody's premises to give them a demonstration was far greater than it certainly is for the lucky salespeople that we have these days.
Absolutely, we're blessed with the advancements that have been made.
You
absolutely.
Certainly are. You don't even know it.
Okay, so I suppose limited variation in terms of what was available, in terms of power, speed. You said there was 95% was 25 watts. What was the other ones available? What was the other power?
You could have 25, 50, or 100.
Okay.
But 50 and 100 were cost prohibitive for most people. So the limitations for application were as well. So nobody was cutting 10 mil acrylic like people do day in, day out these days, because you simply didn't have the power to do so.
Yeah, not on a 25 watt machine certainly would be a struggle. Okay, in terms of those laser tubes, we're obviously going to mention laser tubes later on. What type of laser tubes were they? What were they made of?
They were metal laser sources.
Okay.
And that was really all you saw in the UK, certainly. And we've got people watching from around the world. So if the experience is different in other countries, it'd be interesting to know about it. Yeah. But going back 22 years ago, there were metal tubes. They all tended to come from one manufacturer. Whereas now, of course, we have a variety of tube sources, tube types that people can choose from for their applications. So choice has changed hugely for the customer these days.
Okay. Well, I mean that I think that gives people a bit of an idea of what it might have been like. Certainly limited sort of availability in terms of the product. Again, we're on the screen there. You can see a few specifications that we've pulled out in terms of maybe what was available 20 years ago against what you can get on a machine today. So again, the speed, power, working area, again, have all have a lot more options available for people, as well as some of the technology as well. So this was obviously advanced, laser engraving technology has advanced over the last 20 years. And this next section is probably going to look at a little bit of how that's happened. So again, what innovations have come in the manufacturing of machines or in the industry in general that have meant laser engravers are where they are today. So what we're going to do now is just show you a quick video of what is available today. So this is a video of an entry-level system and a higher-end system. So you've got an idea of what the options are available maybe for a laser engraver today. So we've got a video coming. So again, that was an example of 2 different laser engraving machines that you can get today. For your information, those were both Trotec machines, so it's not the case that we think well, one's better than the other, but they fit different niches in terms of what maybe a customer is required of a laser. So again, there's a lot more choice, I think, is the first instance I would say, as what's the advancements have been made from 20 years ago. So specifically moving on, we look at any machine really, whether that's a laser or a CNC machine or a printer, needs good rigidity and build quality. So this is something, a good foundation that they need. With a laser specifically, what we're doing is we're emitting a beam of light. This is then traveling over maybe several meters, reflecting off a couple of mirrors before it hits the lens and then your material. So this needs to be moving in the laser beam's moving in a straight line. Your machine needs to be in a straight line, be able to put it in a straight line effectively. So again, even if this is slightly off, or as Brian said, if you're moving it for a demonstration, and the rigidity isn't quite there and you need to realign it all the time, this is something that can really impact you in terms of your maintenance schedule. So it might be something that you'd be maintaining a machine, doing this once a week or once a month or whatever, whereas maybe some of the higher end systems today, you may never need to do it, or you do it once a year on your annual service, that kind of thing. So again, the rigidity really helps you in terms of the maintenance and the productivity of your machine. In terms of the productivity as well, having a firmer base means that you can drive the machine quicker as well. So again, the speeds we're seeing today are only really able to be achieved because we've got a rigid base to start from. We then move on, I suppose, to the heartbeat of the laser machine itself, which is the laser tube. So we're talking CO2 tubes for a moment. So this is the CO2 gas tubes, which most people would be using for engraving. And as 20 years ago, Brian alluded to earlier, your choice was a metal tube, 25 watts. I mean, maybe a 50 watt or 100 watt if you had a specific application. But there's a limited range of options available. Over the years, technology has moved on. And Trotec were the first to introduce a ceramic laser tube to laser engravers. Again, this is talking about the UK market, excuse me, the UK market in general. So a ceramic laser is a higher end solution to the metal tube. This is basically achieved because of the way the material the ceramic tube is made from and the way it's produced as well. And this allows the ceramic tube to have a higher pressure or higher density of gas inside the tube, and this allows us to have a faster reaction time, a faster pulse rate. So if you imagine you're pulsing a laser, it's continually pulsing, you get to a point where you're moving that head too fast for it to keep up with the pulses, whereas obviously ceramic tube, you've got a higher pulse rate, so you can drive that head faster and keep the quality at the higher speeds. The way it's made obviously is also increases the longevity, so it's roughly about twice as long lasting as a metal tube and so reducing your maintenance, required maintenance on that as well. And I suppose maybe the sort of key feature I would say is the control you have on the output as well. So today what we're seeing is 20 years ago, Brian was saying you might see 25 watts, 50 watts in terms of the power of the laser tube. Today we're generally seeing sort of between 80 and 120 watts as a standard. So roughly 100 watts, so roughly 4 times faster, 4 times more powerful, sorry, than what we had. And that's really helping us to cut the thicker material. So if you're cutting sort of thick acrylic, 10 mil, 15 mil acrylic, you need that power to be able to cut it effectively. But at the same time, that one job might be 15 mil acrylic. The next job might be some paper or some label stock that you want to kiss cut and not go through the backing paper of. So this, you need to have a higher degree of control at the top end and also at the lower end, and a ceramic tube will enable you to do that with that higher pressure. So as well as that, we've had an introduction at maybe the more entry-level side, which is the glass tubes. So glass tubes are introduced to the market, and they are a slower pulsing and reacting laser tube than the metal and ceramic tubes. You might find them, I suppose, technically in engravers that, you know, they might state they can do a meter per second travel speed, but realistically looking at the sort of 300 to 500 millimeters per second. Again, this is because, you know, that pulse rate, they can't turn on and off it quickly enough, that pulse to engrave at higher speeds. And this is opposed to, say, the 4,300 millimeters a second you can get on a ceramic tube. So, well, you know, more than 10 times faster on a ceramic tube is possible even today with today's technology. That's not knocking this glass tube. Obviously, they've got a certain price point and entry level into the market, and they're also pretty good for laser cutting as well. So generally, we find them in laser cutters rather than laser engravers. So all this innovation, all this gives us choice effectively. So this is more choice to meet your requirements. So if you've got a certain requirement, you have there's more availability in the market to meet that requirement. And again, choice is always better for you. Again, if you've got any questions, usually laser tubes are the one thing that gives us the most questions. So if you've got any questions, please post them in the chat, and again, we will answer them as we go along or at the end. We then move on from CO2 laser tubes to dual source machines. So this was so perhaps, you know, 20 years ago, fiber lasers weren't really on the market. This is a different way of producing a laser pulse. So it's using a fiber optic laser. And what this adds to a CO2 laser is the availability to do more materials. So this is directly impacting onto metal and some plastics effectively. Again, we've got a short video here of the flex application, which was Trotec's introduction, you know, the first to introduce the two lasers in one machine to the market. So again, we've got a little short video here that will hopefully explain it a lot better than I can. So again, you can see there. I suppose the main benefit for the dual source machine is the flexibility. So if you look at the image on the right hand side, you've got the knives with the engraving on the metal and the wood. This is the case of before you might have had to put the knives onto a jig into one machine, engraved one part of it, and then took them out to another machine and engraved the other part. Whereas now you can put them in one machine, and you don't even need to change the lenses these days. It's just a case of send the job, and it will do the engraving on the metal and then the engraving on the wood, selecting the laser tube that you require. So again, ease of use, much more flexibility in terms of the applications you can achieve. Another innovation was the camera system, and again, Trotec were the first to introduce this to a laser system. Again, this is something that you might see on a lot of different machines these days, but a camera system is a way of taking a printed graphic and then using registration marks to find those points and then cut around a graphic. This is obviously to do it very accurately and very quickly. If you're not using a camera system and you're trying to do this work, for example, you might have a lot of wastage because you're not always going to get it aligned correctly, and you might have a bit of setup time as well. So again, time and materials is a key thing to be saved for a camera system. And yeah, again, it's one of those things where it's revolutionized really, certainly printing onto thicker materials. So you're printing onto the things like a knife can't cut. So a couple of mil thick acrylic, for example, and other things like that. We then look at the motion control system of the laser systems. So this really is developed over time. So again, you have the different motors. So you've got stepper motors, you've got servo motors. Stepper motors are generally in the lower end because they're pretty good at low speeds, whereas when they get to higher speeds, they're not very good in terms of the torque they can produce. So that's where you have the servo motors, and those existed back in the day. So that you still had servo motors and stepper motors in the machines 20 years ago, but they've obviously advanced over time. But where you see the real benefit is the motion control system, and this is where I suppose you're doing a practice run before the cut line. So this is where it does a simulation in the software before it actually does the real job. If you imagine it's like a racing driver going around a racetrack, how much it's got to slow down in curves depends on how tight the curve is. And if he has a practice run beforehand, he kind of knows what the track's doing, and so he can adjust that and maximize the speed. So you get a lot faster in terms of the cutting speed. Again, we've got a little video here to show the Trotec Optimotion software, which we've got on our Speedy 400. So again, you see the advancements in the motion control system, and really to sort of, I suppose, bring that to life. Brian, what was it like cutting in the 20 years ago? Were you getting accurate cuts based compared to what we've got today?
Well, the early machines that I worked with were primarily engravers. So people use them for cutting, but with the best one in the world, the circles were 50p pieces. There was a very pronounced start and stop point everywhere you went. It was not really what they were designed to do.
Yeah.
Whereas these days, all the machines right from the low end are really good cutters as well as engravers.
Yeah, no, exactly. It's something that there's really, I've noticed it certainly working in, working in lasers for the last 3 years, but before that, when I was looking at lasers from afar, it was just certainly something that at the beginning they were getting better at doing. So yeah, it's definitely something to notice in terms of the advancements that were made there. So that was, I suppose, the hardware side. Now we perhaps turn our attention to the software. There have been numerous advancements over the years in terms of software. I suppose the sort of main thing really is computers have got faster. They double in their speed every 2.5 years or so. So in the last 20 years, that's increased significantly, and everything's become more powerful and faster acting. But there's obviously features that have been developed over time specifically for laser engraving that have really sort of helped. I suppose picking out two that I would say that perhaps I use the most these days are job time calculations. So this gives you an accurate assessment of how long that job's going to take. So whether it be an engraving job or cut job or different components of that job, it gives you a time based on the artwork that you've put in. So you can use this for costing your job. So before you even do the job, you can mock up an example of this, for example, and you can put it in the software, and it can give you a time. And if you're working on costing, say, using £1 or £1.50 per minute of laser time, you can more accurately cost your jobs and hopefully win more business based on that. You can also plan your production. So, for example, if you've got a job that you know is going to take 3 hours to do, you might not want to start it at 4:30 on a Friday, depending on how what hours you work, obviously. But that sort of thing can really sort of help in terms of planning and costing. You've also got another one, I suppose, that I would say is the variable data and plate production. This is something that really helps when you're talking about labeling or serialization plates. This is where you add data from a spreadsheet. So if you imagine you've got, even if it's simply a case of, a name that's changed and you've got, 1,000 labels to do, typing out that name, different names every time, changing that label, pressing print, bit laborious in terms of time, whereas you can have the spreadsheet link that into designing one label, and then they merge them together to create all your labels. So again, really great in terms of time saving, in terms of productivity. Again, there's a few others that I'd sort of mention, vector ordering in terms of making your cut jobs quicker, nesting as well to maximize material usage, and all sorts of other inventions. Again, there's probably numerous ones there. Maybe you can put in chat which one you think is the most in terms of the software side specifically. But again, there's probably too many to mention really at the moment. This is also a good place to introduce Trotec's new software. This is a new software platform that we're currently asking some of our customers to join in our closed beta test. This is a job management software, so it's got design and output functionality, as well as the job management functionality itself. It's a web-based platform, and the concept is to reduce time from idea to product. And I think looking back over at what software gives you, that's kind of what you get from software. It's to reduce the time from the idea or concept to outputting. And again, obviously complexity has been increased as well. So again, if you're interested in that software, if you're a Trotec customer, then please contact your local Trotec office and they'll be able to talk to you about that. There's a few other inventions, I suppose, that I'd like to mention, which maybe are more quality of life or safety orientated, that we'd sort of mention. They're things like the multifunctional table concept, which allows you to use different types of engraving table or cutting table, so you don't have to maybe shim up materials like you did in the past. It's a much more sort of flexible way of working with a laser with different materials. You've also got autofocus functionality, and certainly the latest sonar technology in the Trotec machines is very easy to use and very quick to use as well, which is brilliant. And then more on the safety side, I suppose you've got the integrated air assists and exhaust systems that turn on and off automatically with your laser system. So this means that obviously there's more or less risk of any issues in terms of forgetting to turn them on, which can happen if you're manually turning them on and off. So I've probably done a little bit too much talking now, so I'll hand over to Brian, and he's got a little bit to talk about materials side. So maybe there's a few benefits in terms of what the material advancements happened over the years for laser engravers. So Brian, over to you.
Thank you. I'd be interested to learn from people that are watching what their experiences are with processing laser materials. But certainly when I first came into the industry, we had two-color laminates, same as we have now, but they weren't laser laminates like we have now. So if you look at a Trolase type of material, back when I first started, that would have been an ABS core material. So engraved absolutely fine, but you couldn't cut it. And one of the limitations for the marketplace and for the equipment itself was the limitations of the consumable products available for it. So everybody in the engraving market used what they called traffolite, which people will be familiar with. Very hard, normally 3-ply or 5-ply material. It'll be here after the rest of us are all gone, that's for sure. It's so hard.
It's like cockroaches, isn't it?
But doesn't laser particularly well. So the consumables people, suppliers, had to catch up with us, had to catch up with the laser market. And as a supplier back then, we gradually saw a switch over from the what we would call mechanical engravable laminates over to laser laminates, followed by exterior grade laser laminates as the suppliers caught up with the demand for sheet plastics. And now, of course, we have indoor, outdoor, self-adhesive, thin, thick, front engrave, back engrave, printable, all sorts of different products to meet almost every application you could possibly wish for, and you can get them all from Trotec. So it's moved on hugely. But the other big thing I think from my experience, for those people who've heard of the Surmark or Thermark products, which gives you a way to mark most metals just using a CO2 laser. When that first came out, that was a big plus for the business I worked in at the time. And this was probably 15, 16 years ago.
Right.
But it allowed us to hit much more industrial markets. All of a sudden, we could be marking stainless steel plates and name tags and cable ties and things like that. The things that had traditionally been mechanical engraving and were time consuming to do. All of a sudden, that product really made a big difference to our business. It was phenomenal, and still heavily used now.
I couldn't imagine it not being available today because so many people still use it. Yeah, no, that's interesting. So
I'm old. I can remember back then.
Yeah, no, I was gonna say, yeah, no, well, those, yeah, I mean, I suppose I couldn't really imagine it without those two today. I suppose I haven't been around with it for the last 3 years, so they've always been available. So yeah, materials is definitely something that a wide variety of materials, and people always obviously come to us all the time with different types of material, and can it cut this, can it engrave this, and sometimes you know because you've done it before or somebody else has done it before, and then sometimes you don't know, so you've got to try it, or you've got an idea.
Products like laserable MDF didn't exist. You might find an MDF that worked better than other MDF, but that didn't work, and laser ply wasn't a product. So all of these things have come along as the numbers of lasers being sold into the marketplace have increased. The suppliers have had to find product to fill these machines up. Yeah,
and probably certainly with wood as well, you get batch issues where one batch will work fine, and then the next batch, they might have used a different glue or something, and it's
for sure, because the suppliers didn't really understand what was needed either.
Yeah.
So it's been a massive step for the laser world. Just the way that the consumable side of the business has kept up now.
No, brilliant. Okay, well, thanks, Brian. What I would say now is that's probably the three things that or the three topics we're covering in terms of hardware, software, and materials. Again, if there's any other things that we maybe haven't mentioned, put it down in chat to let us know, and we'll have a chat about it later. And also, if you've got any questions specifically on any of the materials or any of the things covered in the presentation, then please drop it down in the chat. Okay, so all those innovations and advancements over the years have brought us basically to what we've got today, which is the Speedy 400 from Trotec, which is the cutting edge laser engraver on the market. So again, you can see some of the specifications there on the slide. So the fastest machine available, 5G acceleration, which is one of the things that really make a difference, and compare it to the previous generation of the Speedy 400. Again, you're probably looking at about 20% faster on average, maybe a little bit more on some applications, and certainly for some of the applications that I've tested it on, it could easily be twice as fast. So yeah, so there's great advancements in the latest technology. Again, we could talk about it, but we've got another little video here as well to show you about it, and you can see it in action. Brilliant. Always love the music in that one. Okay, so that kind of leads us to the end of the presentation part of this webinar. We're going to move on to the chat now. But before we do, what I just want to, I suppose what we'll kick it off with is we've seen what's been around 20 years ago and the advancements that have brought us to where we are today. What is, Brian, what would you say is maybe the advancements that you're thinking that might happen in the next 5 to 10 years that are really going to make the most impact with the laser engravers?
I would say that we're a very impatient generation, and therefore the likelihood is that we're just going to get faster and more powerful. We seem to want everything yesterday. You order from Amazon, it arrives the following day. The same demands come of our customers. Their customers want everything next day in most environments. So we're just going to keep getting faster, and you need that power to go with the speed. Otherwise, the speed is not effective.
Yeah, I think Brian's going to be pleased to hear that, based on his comment there. Yeah,
and I couldn't agree more, Ryan. The speed of these things these days compared to what I saw many years ago is phenomenal.
Yeah, no, exactly. So yeah, so generally you kind of see that with technology anyway, gets faster, more powerful, maybe a few more applications. Obviously, Trotec have just launched the new the new software. Which is based on the web. So I think that's where we're seeing software go as well, because a lot of the design softwares and everybody's talking about cloud computing and Internet of Things and those kind of, I suppose, buzzwords. Is that sort of where you see the software side going as well?
Right, I'd have thought so. Everyone's looking more deeply at their own business and their own processes these days. The ability to understand your own processes and take data from what you're doing, I think, will become more and more crucial. And the better that your job management software is, the better you can do that, because we're working with fine margins a lot of the time. If you can save 5% time here and 5% time there, it makes a big difference to the bottom line come the end of the year.
Yeah, no, exactly. It's 5 minutes here or there might not seem much in an hour, but when you talk about it over a year, that could be several days worth of time saved. We've got a comment or a question here. Please, more information about variable data handling. I've asked numerous times how this is done. Variable data, it depends on the software you're using. So I mean, I know in CorelDRAW you use the print merge function. I think there's other softwares that you can use. Engrave Studio, I think. Engrave Lab is something that you can use the variable data in as well. I'm not sure, Brian, if you've got any other suggestions on that. I'm not sure what the question is. I mean, it's definitely a design software.
Yes, it's done at the software side. It's done at the software side, not at the machine side, generally speaking. But if Jason could elaborate and tell us what he's using already, then we'll see if we can give him an answer to that.
Another question from Ryan. A question I'm sure people might have is, how can a person stop the laser from moving all around from the cut to cut in the laser bed? The vector ordering does help only to a point. Yeah, there's I mean, asking the software to analyze your cut file based on the making the small amounts of movement, there's going to be a limit to what it can do. Now what we've got is there's a relatively new software from Trotec called Job Control Cut. So this is kind of like an add-on for job control, and it gives you a bit of flexibility in terms of that. So you can choose features like lead-ins, lead-outs. You've got direction of cut, that sort of stuff. But it depends how complicated your file is, really. And usually what happens is graphic softwares, it's the order that the graphics created in that's the order it will cut. Now, depending on what graphic software you're using, I mean, CorelDRAW's got things like merging sections. So if you've got, effectively, it's like if you've got a circle, if you've copied a bitmap, for example, then it does it in like bits, then you could, maybe recreate that, or you can join them up and reduce the nodes. There's lots of different options. But yeah, the software algorithms will take you so far. But again,
but if you're a Trotec user, then ask your local office about job control cut, because that will help you.
Yeah, that's probably the thing we would say has got a massive impact. But again, if you're looking on the design side, it depends what design software you're using. So see, we've got people from all over the place: South Africa, Scotland, Northern Ireland, England.
And
Belgium,
we've got Paul from Wolverhampton University.
Oh,
hi Paul. We manufacture numerous scale architectural models. Our students spend a lot of time slicing their 3D CAD models into layers. Layers that suit material.
There's a second part to that.
And then assemble to rebuild the models. Are there any future plans to develop the Trotec software to enable slicing, as 3D printers currently do, to STL files? The simple answer to that, Paul, is not as far as I know. I see where you're coming from, but obviously your students can cut them down already. I've not seen anything in the pipeline that's likely to do that, I'm afraid.
Yeah, I think there is software out there that can do that already. So whether it's something that we look at, it might be something that I suppose is looked at. Only 200 characters. Oh, I guess that's for mechanical. Sorry.
No problem.
Oh right, yes. Sorry. Limitations on technology. Eh? Yeah, there it is. Using Illustrator design software. So Jason's asked, using Illustrator design software, third party. We have a Trotec and a laser machine from another manufacturer. Their software handles all variables, and I guess there's a second part to that. Please more. That's one we've had before. Okay, so that was specifically for Illustrator. I must admit, I'm not the most expert on variable data in Illustrator.
What we'll do is, Jason, we know who you are, Jason. So we'll get somebody to contact you locally, because this is more than a 2-minute conversation. That.
Yeah.
But we'll get your local rep to give you a shout if that works.
Perfect. The new Speedy 400 needs to be seen to understand fast. Yes, absolutely. It is incredible in terms of how fast it actually moves. Yeah, the speed is mind blowing. I would agree. I'm lucky enough to see that in my showroom in Dublin, I had both machines at the same time, so I sort of fired them both up and did the same job on both, and it was, yeah, you could sort of see the difference between what was the previous fastest machine available to now the new one. So yeah, it was a massive increase in speed. I would like to see, David said, I would like to see a simpler system for changing the charcoal in filters in the Atmos units. Oh, okay, yeah, it's a bit dusty, isn't it, I suppose, with the bags. So yeah, maybe something that we could use to make that a little bit easier.
We can feed that back.
We will.
Alberto says, how do we compensate the kerf width? Is the new software offering this feature?
It does indeed. Job Control Cut has the option to allow a kerf, so you can either use that on an internal or an external cut. So you can add the kerf width, and the kerf width is basically the width of the cut. So the laser beam will have a thickness or a diameter. So I don't know, usually between 0.1 and 0.2 of a millimeter. It might be a little bit more if you're cutting something thicker. And then this gives you, you can factor that in effectively, so the software knows, and it will just offset the lines a little bit. So yeah, that is in Job Control Cut. So again, if you're interested, contact your local Trotec office, and they should be able to tell you more about that. Okay, I think that might be the end of the question, so we'll probably wrap it up here. We're probably about time anyway, so yeah, thank you very much for keeping us company and your questions today. Again, we've had people from all over the world, really, I suppose, today. So Canada, Poland, Italy, Scotland, Northern Ireland, obviously the UK as well. South Africa. So thank you very much for joining us. This is something that we're going to try and do a bit more regularly from the UK. So hopefully it's something that's been interesting for you, and we'll look to bring you more topics in the future. Along with that, if there's any specific topic you want us to cover in this perhaps more presentational style webinar, then please let us know afterwards, and we can maybe work on that.
Yeah, we welcome any feedback, because this is the first webinar we've done in the UK. So good or bad, we welcome it. It's
all going to be good, Bri. So again, if you have any questions that you think about after watching this, get in touch with us as well. You're welcome. Thanks. Again, this video will be available on the YouTube channel. So if you want to watch it back to go over anything again, you can. Moving forward, obviously we've got the usual social media channels. So the Facebooks, Instagrams, LinkedIn, Twitter, and YouTube. Remember to subscribe to the YouTube channel. Again, you'll get a notification of when we're going to launch a new webinar or a new video. Again, they're all very useful. Join the community. Again, comments and suggestions always welcome. And I think that's probably about it. Brian, have you got anything to add to that?
Just to say that online demonstrations are available. So if there's anything that you want to see for real in the flesh, we're all set up now. We've got cameras around in the showrooms, so feel free, get in touch, and we can organise online demos.
As you can see, yeah, we're all set up to do online demos now. So if you're interested in those, get in touch. Well, thank you very much, Brian, and thank you everybody else for what has been our first webinar, hopefully the first of many. Again, thank you for attending, and have a great evening. So goodbye.